Hi, you are welcome back to Tita Think. Please subscribe to this channel. YouTube statistic is telling me that most of you here are watching my video but are not subscribing to the channel. Please do support this work if this has been very useful to you. My name is Daniel and I'll be taking you through linear first order differential equation example number 2. Subscribe before we start. Alright, so we did a previous video. I've already done previous videos for this same topic. There's a first example under this same topic. You can locate this in that video in this same playlist. There is an introduction for this. This will help you to know that for the solution of a first order linear differential equation, you need to multiply the function through with what we call the integrating factor. So I've done 2 proving videos for that. It is very good. It will help you to really get the concept. So for this second example, we have x plus 1 multiplied by the first derivative dy dx plus the variable y equal to x plus 1 all square. So this is a first order linear differential equation. But before that, I'll take you to the formula for first order linear differential equation. So we learned that the linear first order differential equation is usually in the form dy dx plus let me use the variable m. So plus m of x equal to let's say L of x. So there is a y here. All right, so the variable y and its derivative is first differential, so it's a first order linear differential equation. And then m of x and L of x, remember these are 2 separate functions in terms of the variable x alone. Put that in mind. So that was what we learned when we did the introduction. So let's go back to the question and see how we can tackle this one. So like I said earlier in the previous video for part 1 of this, the first thing you need to do is to make sure that you have your differential function dy dx standing alone. When I say standing alone, remove any other function that is multiplying the derivative function and then separate it to the other side. So let me do that. Once we are able to do that, then we can continue with the calculation. So the first thing I'll do is to divide through by x plus 1 to get rid of whatever function I have here so that I can maintain my dy dx. So we have our x plus 1. Let me divide this for you to see. X plus 1 dy dx plus y over x plus 1 equal to x plus 1 all square dividing x plus 1. So we can now get rid of the first x plus 1 and we are left with this. So we have our derivative function dy dx plus 1 over x plus 1 times y equal to, so whatever we have here is a repeated function. We can cancel one of these. It is the same as having x plus 1 multiplying x plus 1. So most of us are aware of this, dividing x plus 1. So this side of the equation. So you can take care of one of these and you'll be left with what? X plus 1. So once I cancel one of these, I'll be left with x plus 1. And that is it. So let me rewrite this equation. Okay, so once we get here, I just decided to factorize y out because y times this one will give me y over x plus 1. Don't forget this is over 1. So those of you that are confused, I want to have the separate function on its own so I can work on that. So once we get here, let's label this equation star like I have done there. Now once we get to equation star, we learned that for first order linear differential equation, the solution can be found when we multiply through by the integrating factor. So how do we find the integrating factor? The next thing you need to do is to compare the equation you have with the equation of first order linear differential equation. So we will compare with this equation, whatever we put here. So it depends on the variables you want to use here. So let's do that. Okay, so now you compare equation star with dy dx plus mxy equal to lx. So now when we compare this equation very well, this is the same as this. Now we have a variable y here. We have our variable y here. So mx equal to what? 1 over x plus 1. So therefore, our mx equal to 1 over x plus 1. Now, we can compare the right hand side of the equation, L of x. So L of x equal to x plus 1. Now, when we get here, we need to find the integrating factor because we will be needing it to multiply through. So our integrating factor IF is always equal to the exponential function integral of what? M of x dx. Remember, it is always the function that is multiplying the variable. So whatever variable you use here, if you are using p of y, then you substitute your p function here. And so this is our integrating factor. Now we can substitute m of x because we know m of x to be 1 over x plus 1. So IF equals e to integral of 1 over x plus 1 dx. Okay, so once you get here, your next step is to make sure you integrate the function at the exponent because I have an integral sign here, so I have to integrate it. Now, how do I integrate? You need to know whatever function you have here and how to integrate it. So we have integral of 1 over x plus 1 dx. And the integral of this will give us ln x plus 1, the natural log of x plus 1. So I'll do that for you to understand. So if we have the function integral of 1 over x plus 1 dx, the first thing you need to do is to consider the denominator and let a variable be equal to the denominator. Remember, the reason why I'm applying this is because whatever I have here is 1. And I need to know that after I differentiate the denominator, the result should be equal to the numerator, so it can be cancelled. Since I have 1, the differential of this will also give me 1. Whatever function I have here, if I differentiate this and it's not equal to that function at the numerator, I cannot apply the method I'm about to use. Then I have to switch to what we call partial fractions. I'm not talking about that. So let's move on. So let's use a variable like u. So we can say that let u be equal to x plus 1. Differentiate the function u with respect to x. So du dx equal to 1. Why? Because when I differentiate the variable x, I'll get 1. The exponent of this variable is 1 at the top here. Use it to multiply the function, reduce the exponent by 1. When I subtract 1 from 1, the result is 0. X to power 0 is 1. Remember, the differential of a constant is also 0, so the result is 1. Now, because I am integrating, look at the dx I have here. I need to make dx here the subject so I can substitute the function. So make dx here the subject. So when I cross multiply here, I'll get du equal to what? Dx, because this times 1, du times 1 at the denominator. Now, go back to the original function, pick the function and introduce your variable. So we use u. So integral of 1 over u, were the same person who said that let x plus 1 be equal to u. So I'll bring it here. And then I have my dx. Dx is the same as what? Du. So dx is equal to du. So I can put it here. So this is it. So now when I integrate 1 over u, the result is ln u plus c. Now, all you need to do is that, what is u? You said that u should be equal to x plus 1. So you can substitute it back. So we have ln x plus 1 plus c. This is it. We have ln x plus 1 plus c. So like I said here, the integral of this will give us ln x plus 1 plus c. So we have our IF equal e ln x plus 1. Now note that I do not need the constant of integration here because I am working with the what? Integrating factor. I don't need the constant of integration since the proving for this, we got rid of the constant of what? Integration. So now we move on from here to the next step. So from here, anytime you have a natural log to the power base e, you can get rid of the natural log and the e. So this will take care of this. You see? So we are left with if equal to x plus 1. So now we have been able to find the integrating factor. The integrating factor is what? X plus 1. Now take the integrating factor and use it to multiply your main equation. Equation star. Use it to multiply equation star. So let's do that. So we take x plus 1 to multiply this whole equation. So we first have x plus 1 dy dx plus 1 over x plus 1 times y times x plus 1 equal to x plus 1 times our integrating factor x plus 1. Now when we get here, it's very simple for us. This one can now take care of this. And we are having x plus 1 dy dx plus y equal to x plus 1 all squared. So now this time this will give us what? X plus 1 all squared. So in our next step, all you need to do is take the derivative on the left hand side and equate it to the right hand side. So the derivative of the integrating factor and the variable y. So you taking derivative on the left hand side. So derivative of the left hand side is giving us d dx into bracket y times x plus 1. So this is our integrating factor, the variable y. Equate this to the right hand side of the equation, x plus 1 all squared. Your next step is to integrate both sides of the equation. So let's introduce the integral sign. We have integral of d dx into y x plus 1 bracket close equal to integral of x plus 1 all squared. So now when we integrate the left hand side of the equation, this will take care of this one. So we are left with y into x plus 1 equal to integral of x plus 1 all squared. You can choose to integrate both sides. So now let's integrate the right hand side of the equation. So let me take you through the basic step. Integral of x plus 1 all square dx. So this is you just say let u be equal to x plus 1. Differentiate this one. We have du dx equal to 1. Make dx the subject because we have dx here. So du equal to dxy. This is over 1. When I cross multiply here, this time this time that. So now dx is the same as du. So rewrite your equation. You have the integral of u because you said that let u be equal to x plus 1. So we rewrite the equation in terms of the variable u. So u squared, and what is dx? Dx is the same as what? Du. Now when you integrate this, this is going to give you 1 out of 3 u to power 3 plus c. So from there, we can now resubstitute the equation for u. So we have 1 out of 3. U is the same as x plus 1 raised to power 3 plus c. So this is the integration of what? X plus 1. So when you get here, you don't need to go through all the steps. All you need to do is to integrate this straightforward. So we have y x plus 1 equal to 1 out of 3 x plus 1 all to power 3 and plus c. So now let's reduce the equation to the simplest form by dividing through by x plus 1 to make y the subject. So we have y x plus 1. This is over x plus 1 equal to 1 out of 3 x plus 1 out of x plus 1. This is cube plus c over x plus 1. So now this can take care of this. Don't forget this is a repeated function. X plus 1 multiplying itself 3 times. So this can cancel one of these and we are left with 2. So we have y equals 1 out of 3 x plus 1 all squared plus c over x plus 1. So you can, this is the final answer. You can leave it here by saying y equal to x plus 1 all squared all over 3 plus c over x plus 1. So this is your final solution. Thank you very much for joining me here, and I'll see you in the next one.